Hello everyone. In today's video, we will see how we can run simple linear regression using R. Of course, multiple regression is also possible, but we will see that in our later videos. So linear regression basically shows us the relationship between the predictor variable or variables in case of multiple regression, which is in social science commonly known as independent variables, and the response variable or the dependent variable. So how these two variables are related, either positively or negatively affecting each other, we will see using linear regression in this case. We have two data vectors here, which we will convert later to data set. First is the height, which we measure from the, like individuals, height and the weight of individuals in this case. We have to run this one first, the height of individuals and weight of the same individuals, of course, the same size. In this case, our observation is a thin in these two variables. So we can produce a data frame by merging these two vectors together and using data frame command, which is available in our base normally. So we run this command, then we have a data now. So after having data, we can view our data here simply using view command. Then we put the name of data here, so that is data simply. And then if we run this one, we can automatically, it comes here and we can see our two variables, height and weight over 10 observations in this case. So this is quite small data, of course, for the sake of only like showing an example for this, how we can run like simple linear regression. This is hypothetical data, and later on, if I have any data which is like real data, I will show you further how we can do this one. So now we have only two variables. To run linear regression, we have lm command in our base. So we will use this lm command. So if you want what is inside this command, you can use like the question mark and then lm. Then if you run this command, you're going to have help in this area under help, so you can read and see what is inside the lm. Basically, there is formula. Formula is like this part. First, we give like the independent variable, and then we give a dependent variable, or in the case of multiple regression, we can give like all variables in the data set. Of course, first we have to clear our data and we have to prepare our data in the form that could actually be suitable for this particular formula or particular analysis. So here we put this title, and then we give this like period to mean that I need to include all variable in my data set. So I give data set data, then my data set name fortunately is data, then I run this command. Then after running this command, basically the equation is written as like this: y is equal to a plus bx. B is coefficient, and x here is like height, and y is weight in this case. Then we print and see what is there. Actually, we can see in this area down here, the printed, output is here. So the intercept for this formula is this one. In this case, A is represented by this, and the coefficient for height is like 0.67 in this case. So now, like a unit increase in height would result like 0.67 kilogram increment in the weight in this case. So if we have, for example, like linear regression, multiple linear regression, the only change is we're going to give this additional variables. This is simply I put here. I would not run this command because there is no data by now, but the basic idea behind the multiple linear regression is simply we use the same command lm because it's linear regression, and then we give a dependent variable here, which is the same weight, and we're going to give these variables additional, like in this case weight is dependent on height of individual, age, and the gender of individual. This is of course hypothetical data. You will go further and you're going to dig it out. So then we will see like further summary of the model. I'm going to increase this area somehow up because it's like many things has been printed to my environment. So intercept and the standard error and other like t, and these values are printed here, but I would see only like these two basic things, which are the measure of accuracy and validity of our model. In this case, we can see here like F statistics, which is very greater than the one, which shows us the robustness of our model in this case. And also we can see the R square, or the coefficient of determination, which is close to the one. So our model is quite robust in this case, and we can see that the height has highly significant contribution or influence on the given variable. In our case is weight in this case. So that is it. You can actually read further how you can interpret these results in your papers. So if we would like to predict, that is the test part. Then after having a test, we would predict. And if we have, for example, the height 170 centimeter, how we can use this is simply we first read this one into our environment. Then we use predict function, and we use the mode that we have already created before, and then we will run this one and we will see the result. So the most probable weight of this individual who have like the height of 170 centimeter would be 76.2 kilogram. We can go here like the height and weight function, and we can locate the person, either it is predicted appropriately or somehow how it is predicted. We can see this one. Then finally we can plot and see how our like the straight line linear line can be fitted on our scatter plot. So we can run here. We're going to give the first height and then weight, then color of the the point in a scatter plot, and then we run this to the environment, and we get here simply the regression line and the scatter plot here, having height against weight, and simply shows the relationship between this. And you can see that as the height of individual increases, the weight of individual, uh, of course, increase with the increasing height. So this is a simple linear regression concept. And this is it for today. And I thank you for watching this video. Please subscribe my channel, and I will come up with the multiple linear regression and other very fantastic R visualization issues. Thank you.